Please subscribe, follow and like engineeringall.com.
Welcome to our behind-the-scenes look at the fascinating process of window glass manufacturing. Today, we'll take you on a mesmerizing journey through the intricate steps that transform raw materials into the clear, durable, and essential material we often take for granted, window glass. As you delve deeper into the world of glassmaking, you'll discover the art and science behind this seemingly simple yet remarkable substance. 1. Raw materials. The foundation of glass. The journey to create high-quality window glass begins with the selection of impeccable raw materials. Silica sand, the primary component, is sourced from various locations worldwide, ensuring the highest purity and quality. Soda ash, derived from natural deposits or synthetic processes, acts as a flux, reducing the melting point of silica. Limestone, another vital ingredient, contributes to the glass's chemical stability. These raw materials undergo rigorous testing and precise measurements to ensure the glass's final composition meets specific requirements, guaranteeing its optical clarity, strength, and durability. 2. Glass furnace. Melting the elements with the raw materials carefully blended, they are introduced into a colossal glass furnace, resembling a fiery inferno. The furnace operates continuously, maintaining temperatures around 1700 degrees Celsius, 3092 degrees Fahrenheit, to melt the raw materials into a molten, glassy substance. The controlled heat, along with precise air and fuel adjustments, ensures that all components mix uniformly, eliminating impurities and achieving the desired homogeneity. 3. Glass formation. The float glass method. As the raw materials fuse together, the molten glass is skillfully drawn from the furnace using the float glass method. In this mesmerizing process, the liquid glass flows onto a bath of molten tin, a metal chosen for its excellent surface properties. The glass spreads and floats on the tin surface, forming a continuous ribbon of uniform thickness. As the ribbon moves along a series of rollers and conveyors, it cools and solidifies, becoming a flat, pristine sheet of glass ready for further processing. 4. Annealing process. Strengthening the glass. After the glass ribbon emerges from the float bath, it proceeds through an annealing layer, a carefully controlled cooling chamber. The annealing process plays a critical role in ensuring the glass's long-term strength and durability. The glass gradually cools at a predetermined rate, allowing any residual stresses from the manufacturing process to dissipate. This stress-relieving step ensures that the finished glass can endure changes in temperature without fracturing, making it suitable for various applications, including windows. 5. Cutting and shaping. Customizing the glass. Once the glass has been properly annealed and cooled, it undergoes precise cutting and shaping. Advanced machinery equipped with diamond-edged cutters slices the large ribbon of glass into smaller, manageable sizes. Tailored for specific window designs or other applications, the glass may undergo additional shaping processes to meet unique requirements, such as curved or tinted windows. 6. Quality control. Ensuring excellence. Quality control is the backbone of the glass-making process. Trained inspectors rigorously examine the glass at every stage, from the raw materials to the final product. High-resolution imaging, automated inspections, and skilled eyes ensure that the glass meets strict industry standards for clarity, thickness, surface smoothness, and overall quality. Any glass not meeting these exacting criteria is recycled back into the manufacturing process, minimizing waste and maximizing efficiency. 7. Coating and insulating. Enhancing performance. In the ever-advancing world of glassmaking, additional processes can further enhance window glass performance. One such process involves applying specialized coatings to the glass surface. Low emissivity, low-E, coatings, for example, reduce the transfer of heat through the glass, enhancing energy efficiency and lowering heating and cooling costs. Other coatings may provide anti-reflective properties, ultraviolet, UV, protection, or self-cleaning capabilities. Insulating glass units, EGUS, commonly known as double or triple glazed windows, are also becoming standard in modern construction. These units consist of multiple glass panes separated by a hermetically sealed airspace. The trapped air acts as an insulating barrier, further improving the window's thermal efficiency and soundproofing properties. 8. Final inspection. Ready for the world. Before window glass products reach your local suppliers, they undergo a comprehensive final inspection to ensure they meet the highest standards. From optical clarity to dimensional accuracy, every aspect is meticulously evaluated. The glass's durability, thermal performance, and safety attributes are tested to ensure it is ready to serve its purpose and provide a clear view of the world outside. Conclusion. And there you have it, the mesmerizing journey of how window glass is made. From the selection of raw materials to the final product, every step in the glass-making process is carefully orchestrated to create the high-quality glass that brightens our homes and connects us with the world outside. The art and science of glass making have evolved over centuries, yielding an extraordinary material that we encounter in various aspects of our daily lives. As you gaze through your windows, take a moment to appreciate the complexity and precision involved in manufacturing this seemingly unassuming material. It is a testament to human ingenuity and craftsmanship, serving as a clear gateway between the comfort of our homes and the wonders of the outside world. Thank you for joining us on this captivating exploration of glassmaking, and we hope you have gained a newfound appreciation for the exceptional process that gives us the gift of window glass.
Thank you for watching. Please hit the red button to subscribe for more videos.